Hello again, Algebra 2 friends. So finally we get to finish the 1.6 lesson. This is the second half of the lesson where we're going to be solving absolute value inequalities, and I really like this lesson because it kind of puts together the last two lessons that we've had. So we're going to talk about those compound inequalities again, the ands and the ors, and we're also going to talk about, what it means to have an absolute value equation, in this case inequality, and how we have to set up two problems because that's how absolute values worked yesterday, right? So this idea of and or is going to come back today. It's going to get a little weird though because the word and the word or doesn't just show up in the problem. We have to know whether we have an and or an or problem. So today's questions are going to start off with some algebra business inside absolute values, and then instead of equations we have these inequalities. So this is really hard to read, I apologize. It says if you have a less than, so I should clarify, if you have a less than, once you've isolated the absolute value and it says like absolute value less than a number, that means you have an and question. So the way I remember that is I think of the less than symbol that looks like an L, and I think it looks like the word land. So sorry out there if you can't read this yellow ink. Yellow is not a good choice, my bad. All right, now on the flip side of that, get it flipped. So absolute value, if you have a greater than symbol for a number, that is an or question. And the way I remember that is greater and or both have R's. For a lot of kids, they just go, well, if it's not and, then it's or, because that's the other one. That's fine. So the hardest part, I think, today is recognizing, do you have an and or an or? And then making sure you utilize those ideas well. So there's two things that you have to do. You have to set up two inequalities like we did yesterday. We set up two equations. This time you got to set up two inequalities, and notice there's two things that change. So the original problem, just you take the bars off and that's all you change for the first one. But for the second setup, you flip the inequality symbol, that's that guy right there. So remember it was a less than, now it's a greater than. And then you negate the solution. So that would be this negative sign that's in front of the 11. So there's two things you got to change. That's kind of annoying. All right, so let's go through this question, which, yep, that's that first one. We were told it was an and, so that was nice. And we're going to go and solve both inequalities just like we did in yesterday's or the last lesson's work. So we're going to subtract 7. And you know what? It's that cool thing where it's the same work everywhere, so I'm just going to do it over here as well so I don't have to change pens out so much. So we have 2x is less than 4. And I'm going to carry the word and down with me because one of the most common mistakes from kids is they don't write down the conjunction and then they have the wrong answer. Picky, I know. All right, 2x is greater than, that would be a negative 18. So here we're going to divide by 2, and that's a positive coefficient, so you don't have to do any additional flipping. And I'm ready to write down my solution. So right here, we end up with x is less than 2. And then key point here, write down the word and then drop this one down, x is greater than negative 9. So remember from our work with ands and ors, ands are like those sandwich questions where you graph in between two values. Just remember sandwich. So just make sure the numbers go in the number line the right way. 2 does not come before negative 9, does it? So negative 9 would be smaller. And then it helps that you are graphing and thinking about what the graph should look like, but still trusting your math. Because if you made a mistake, like if you didn't flip your sign properly here, when you set up the second one, you'd catch it. So I want everything less than 2 and greater than negative 9. And that would definitely be the numbers that are in between them. They both have parentheses on them because there's no equal to symbols anywhere. And I'm ready for my interval. So my interval goes from negative 9 to 2 in that order, parentheses on both. Sometimes I get kids who are like, how do I know that's not an ordered pair? Well, it's the context, right? If we're not doing ordered pair work in math, why would I randomly write down an ordered pair? All right, math is weird like that. Okay, so this one was already set up for you. We found out it was an or, and then remember there's two things that they changed on the second problem. The first one, they just took off the bars. The second one, they flipped the inequality and they negated the answer. Those are the two changes. So now we solve. All right, we're going to add 2. And again, same work, different solution. Add 2 over here as well. So we have 3x is fraction. All right, greater than or equal to 10. I'm going to bring the or with me. 3x is less than or equal to negative 6. And then divide both sides by 3. Now here, fraction, decimal, I really don't care. Fractions are easier and less work because you don't have to go reach for a calculator or think really hard about how to divide 10 by 3. So I will always go fraction. X, because I'm lazy. X is greater than or equal to 10/3. Don't forget the word or. X is less than or equal to, now you don't flip the sign because the coefficient wasn't negative, right? It already was flipped originally in the problem. Don't flip it again. All right, -2. So which number shows up first on the number line? That would be the negative number in this case. So -2 versus a 10/3 in that order. And then I think about what oars look like. Oars were oars on a boat where they kicked out. We did have that special case in our notes where they overlapped. That usually doesn't happen. And we'll talk about when it does happen in a little later in the lesson. So everything less than or equal to -2 would be kicking out this way. Or anything greater than or equal to 10/3 would be kicking out this way. So these are the weird ones. You got to remember that negative infinity lives down here and positive infinity lives up here. So your interval, your coloring of your number line starts at negative infinity, always a parenthesis on negative infinity, and then it keeps coloring until -2 with a bracket. It jumps over a whole bunch of stuff, so we're going to use the union symbol, and then it picks up again at 10/3, and then it keeps coloring until positive infinity. So I really like this unit in algebra. It just builds so nicely. You know, our work with the number lines earlier, and then we ended up doing absolute values, and great work. All right, so this one is not set up for you at all. The good news is the absolute value bars are isolated, so you don't have to worry about isolation on this first step, and we're ready to just jump into the setup. So the first thing I want to point out to you is this symbol right here. That is a greater than, which means we are going to set up an or. So the first problem, I just take the absolute value bars off. I don't change anything else. So 4x plus 10 is greater than 2. Or, now I don't change the algebra, the 4x plus 10, but I do change two things. I flip the inequality to a less than, and I put a negative in front of the 2. So those are two things that I changed. I reversed the sign and I negated the answer. So now we solve. Good news. Same work, two different problems. The setup is probably, it is most definitely the most crucial part of the question, and really can take you off in a bad direction if you don't have it set up right. So 4x is greater than, I can do this, all right, -8. I'm going to bring the word or down. And then 4x is less than, that's a -12. All right, one more step and then we're there for the solution. Again, I really wish I wrote smaller. Sorry guys, I hope you have enough room. All right, so my solution says x is greater than -2, or x is less than -3. So I think to myself about what an or should look like. And oars should look like oars on a boat. They should kick out, unless it's one of those weird special cases. Now, my experience tells me this is not a special case because there's no stars on the problem. My teacher put stars. So we think about what is smaller. Be careful. We have -2 and -3. -3 shows up first on the number line. All right, let's get graphing. So I want everything greater than -2. Notice there's no equal to there. Or anything less than -3. All right, it's a weird one. Here we go. My interval. If I think about where it starts way down here at -infinity. And then it colored solutions until -3. Jumped over a bunch of nothing. Not really that much. But there are, if you want to argue, there's a ton of numbers in between -3 and -2, right? All those rational numbers in between. Decimals, fractions. All right, and then picks up again at -2, and then continues on until positive infinity. Woo, that was a good time. All right. So these have the most, they're the most laborious problems. This one has stars. I can't be good, right? All right, so let's first of all talk about the fact that it has a greater than symbol. So this is going to be, so because this is greater, that means we have an or. So it should be kicking out like oars on a boat, right? I'm going to go through the work on this one, and then I'm going to talk about how we could have taken a shortcut. I know that's frustrating when teachers do that, but just FYI. Some of you out there on the internet are like, stop all your work. Well, let's go through it anyways. So 2x plus 3 is greater than or equal to -4. So right away your brain should be like, that's weird. And then 2x plus 3. So two things you're changing for me. You're flipping the sign to a less than or equal to. And then you're negating a -4. Again, your brain should be like, this is weird. So -4 would be a +4. All right, we're going to solve. I'm going to subtract 3. Really wish I wrote smaller. Oh boy. All right. So I have 2x is greater than or equal to -7, or 2x is less than or equal to 1. Now, I'm not real happy because I got to divide by 2 and I got a bunch of fractions, right? Oh boy. Okay. I wonder if I can move my stuff down without really ruining everything. Kinda. Okay, I'm gonna scooch this over. There we go, much better. All right, so your solution right here, we got x is greater than or equal to -7/2. If the fraction part's bothering you, go ahead and call it a decimal so you can do a little more comparison. And of course, everyone knows what 1/2 is. It's a 0.5. So think about your answers here, guys. You got -3.5 or 7/2. And then positive 0.5. And I know they're supposed to kick out, right? Oars on a boat. Well, everything greater than or equal to 3.5 would have been this way. Or anything less than or equal to 0.5 would have been everything this way. And it has nothing to do with where they overlap. It's just everything gets colored. So this is one of those special cases where it was all solutions. So your interval stretches from -infinity to +infinity. All right, so here, let's back up all the way to the beginning of the problem. The question, just look at it. It's asking you way at the beginning of this problem, gosh, this slide's going to be ugly. It's saying, when is an absolute value bigger, because greater than or equal to would be bigger than a negative? And the answer to that is always. Remember, one of those rules was an absolute value of any number is going to come out to a positive value. So when will I get a number bigger than -4? All the stinking time. And that's why the solution comes out to be all solutions from -infinity to +infinity. So if you have what are called a special case, or basically a trick question, like the next one, you are welcome to stop and think. And there are some like this on your homework. Now, big problem here. We are not isolated yet. Your absolute value bar stuff, it has to be isolated. So we're going to have to do that. I'm going to subtract 8 from both sides. Oh boy, now I see why it starred. So the problem really says the absolute value of 4x minus 9 is less than or equal to -3. So that's why this guy's got stars all over it. So I want you to write a note in your notes. And I want you to say stop and think. So it's asking you, when will an absolute value be, now be careful, this is a less than symbol, right? This says less than. Be smaller than -3. And the answer to that question is never. So had you gone through all the work, you would have got an and problem because it was less than. And then you would have saw, like, ands are supposed to overlap. Wherever their shadings overlap is where you actually have your solution. Well, when you tried to graph yours, your shadings would have kicked out. So they don't overlap. So hopefully you would have caught your mistake there. Turns out, most kids who go through that effort of solving don't catch their mistake. So you definitely want to be careful. If it's feeling like, oh man, I don't remember our problems doing this. Like right away when you saw a less than or equal to -3, your brain should have been like, that's weird. I don't remember that happening. So you can't graph it because there is no solution. Don't put that 0 with a line through it symbol. We'll save that for something else in math, not for this, okay? All right, so again, we need to isolate on this question. I'm going to write a little note to myself in my notes. I think this is our last question. So isolating first, I'm going to add this 4 over. Very critical step, guys. The most common mistake on this question would be kids don't isolate before they work. So the true problem here is the absolute value of -x plus 5 is greater than 10. So the fact that absolute value, when it's isolated, has a greater than symbol, that means we have an or. I almost said the wrong thing. Hello, dyslexia. All right, so we're going to set up our two problems. The first one, you just take the bars off. So you say -x plus 5 is greater than 10. Or, and then don't change the algebra, -x plus 5. But you do change two things here, right? You make this a less than, and you make it a -10. All right, now it's time for solving. We're going to subtract 5 from both sides, and actually both inequalities. Kind of nice. So -x is greater than 5, or -x is less than -15. All right, one more step and we're home free for the solution. Oh boy, I hope you don't forget this next step. We're dividing both sides by a coefficient of -1. So on top of all this other knowledge, we have to also remember the older knowledge of anytime I divide an inequality by a negative at any point in my work, my signs flip and they reverse. So your real solution is x is less than -5, or x is, now this will flip back to a greater than 15. Oh, that's so annoying. All right, so right here you might want to say flip or reverse. You know, it's a lot of notes to self, man. All right, -5 would show up first on the number line. And remember, we have an or, so it should be kicking out like oars on a boat. Everything less than -5 would be this away, feeling like an oars on a boat, yep. And everything greater than 15 would be this away. So my solution in interval notation, think about the infinities. It starts off at -infinity, and then we colored until -5. I jumped over a whole bunch of nothing. No solutions between there. So a union symbol is used, and then it picks up again at 15 and keeps coloring solutions until positive infinity. And there you go. All three solutions: solution form, graphing form, and interval form. Whew. All right, I feel a little bad because there wasn't a lot of examples of ands on that problem, because the one and that we tried to do was a weird, like, no solution one. So make sure that you're careful, like here. Oh man, if I had my life to live over again, that guy should be a less than. Yeah, I'll fix it. All right. Don't be surprised if you're looking at your notes and that problem is totally different than the one I just did. Live and learn, a bruiser. All right, so remember, ors should be kicking out unless they're a special case, and should be overlapping in between the two numbers. Always follow your math and make sure that your graph and your math are matching and your logic follows as well. Practice, practice, practice. This is not exactly easy stuff, but we are going to use this to build forward in our algebra career. So have a good handle on it. All right, good luck, everybody.